Alright, hi, my name is Dr. Melanie Stock and I am USU Extension's Urban and Small Farms Specialist. Today we're here with the Small Farms team and we will be assembling a high tunnel in record speed. The students have already done in assembling this high tunnel, which is 42 feet by 14 feet wide by 7 feet tall, is they have pounded in the rebar. So each piece of rebar is 2 feet long. And as you can see here along the ground, they've put in 14 pieces of rebar on either side. And so that is going to help anchor the high tunnel ribs to the ground and make sure that it can stand up in a storm. So now that that work is done, we will actually be assembling these different rib pieces. So there's one other person who I want to introduce today, and that is James Frisbee. James runs the Greenville farm here and works with our students on a daily basis and really is the keeper of a lot of the knowledge here. So we will be installing the ribs now of the high tunnel, and one thing I want to address before we get started are some common mistakes that people tend to make in developing high tunnels according to their intuition. So some tried and true methods that we have here are first using a single piece of PVC. So this one, these here are 24 feet long, and I think some people go into it buying shorter pieces or buying couplers and putting in a lot of extra couplers thinking that that's going to help with the strength of it. However, especially in areas where we have a lot of snowfall, that actually reduces the strength of the high tunnel. So to avoid collapse, one key method to go with right away is to get long PVC pipe. Here in this case, again, it's 24 feet long in order for us to reach our width and height and length preferences, and so we'll do that going forward.
It's a 20-foot.
We've quickly assembled the ribs of the high tunnel. We will be adding on an end wall. And so the end wall is just like what it sounds. The piece that goes on the end that has a door that we can go in and out of, and it also has a window that we can use for ventilation. So between the door and the window, we can really control for temperature. So we won't go into the exact dimensions of this end wall here, but if you take a look at our USU Extension fact sheets on designing a high tunnel, it gives all of the specifications for how to cut the 2x4s and assemble this sort of end wall. Now right now, Megan over here is using a drill to drill a hole right through the piece here so that it can lie right on top of some of the rebar for extra stability. Could we start measuring the next one? Should we do it the other way so the thing is the other way?
Make it much easier.
Again, before we do that.
Wait, do you want to move that down? Oh no, let's leave it there.
So as you can see, we're adding a lot of hardware on right now. We have different clips in order to secure the T-posts, and then we're also going to be securing the PVC to the end wall. But before doing that, the important thing is that there's a little coupler that goes on, and that's in order to secure the top part. So now they're having extra security with this end wall.
Do you want the water? Yeah, then we bring it down here to the river. Like the ladder.
Okay.
Good. Maybe we should wait till they're all up. We could
just put them on loosely. Do you want the... All right, so we have finished the assembling of our new high tunnel here in June, and we're going to keep it the way it is for now because we'll be planting dahlias in it, and we really don't need the plastic covering or the shading right now. So I just want to show you this high tunnel real quickly. This high tunnel is complete, and so here you can see the end wall is in place, and we've also attached a door to it. And the special thing about the door is first that one, it's latched shut, so we can open it if we want, and we'll show you that in a bit. But the other option that it has here are these latches to include a window. And so both of the end walls on either side of the tunnel look the same. So there's that same kind of door and window setup. And what this allows us to do is vary our venting. So on days in the winter, it could be February, for example, where we have a bright sun and it's still relatively cool out. If we want to vent the high tunnels just a little bit, we can open up the windows on either side to get that cross ventilation and keep the tunnels from getting too hot. We've certainly had February days where we've forgotten to open up the doors or windows and it's gotten to be over 100 degrees in there. So venting's really important. One way to do it is with a window for earlier in the season. Kind of the next layer on top of that is not only the window, but then to fully open each of the doors. And so we open the doors a lot of times in April and May when it's really starting to heat up outside to allow us to cool things off. So here, if we're to open the door, you can see inside, and we've got beds planted on either side, and we also have an air temperature sensor that also records humidity in there. And so that's really important in managing your high tunnel system, whether it be a temperature sensor that automatically records or even putting a thermometer in there, but to really keep an eye and know exactly what the temperature is inside, because even though it may seem cool outside, it's quite a different environment inside. So we've talked about adding a door on that has a window for ventilation. The last thing that we can do, and here this high tunnel has shade cloth, but say we still had plastic on top, what we'll do is we'll actually open up the sides. So this bottom 2 or 3 feet, when we have plastic on, we can roll that up and allow for even more ventilation, and that's been really important for us in May and June. After that stage, it can be important to take the plastic off because we really don't want to heat any more, and include this shade cloth. And so that's been really great here for us to keep the temperatures a little bit more moderate, and for our cool season plants to have slightly gentler conditions, so not the intensity of that solar radiation by way of the shade cloth.